In aerodynamics, there are four forces that act upon anything that tries to fly. These forces consist of weight, lift, drag, and thrust. If something were to have too much weight and not enough lift, or too much drag and not enough thrust, it would theoretically not be able to fly. Think of a large plane with little wings and small engines. It most likely weighs too much. It has too much surface area, so the wind will push it back and not allow it to come forward, so that causes drag. And with the small engines and tiny wings, there's no lift and no thrust. Nobody would expect anything like this to be able to fly. However, there are exceptions to just about everything, and Bombus impatiens, or the bumblebee,
just so happens to be one of them.
A study in 1934 was performed by a French entomologist named Auguste Magnum, along with the help of his assistant André Saint-Lay. In this study, they calculated that aerodynamically, the bumblebee or any other insects like the bumblebee should not be able to fly.
As you can see here in this drawing, the bumblebee's body is quite large compared to its small wings.
Based on the laws of aerodynamics, the bee's weight should be too much for its wings to be able to fly. The wings should not be able to provide enough lift nor thrust for the species to even get off the ground. But, like the stubborn creature it is, the bee continues to fly anyway. Years later, scientists still struggle with the concept of bee flight. The calculations proved that the bee should not be able to fly.
None of this was making any logical sense to these scientists.
And based on their further knowledge of physics and aerodynamics, this concept was still supposedly scientifically impossible. Or was it?
Bees have perplexed scientists for decades, with each generation gathering more and more information on the stunning question of bees. And a study in the 70s showed that a key component to bee flight is the abundance of lift needed to take off.
Torkel Weisfeld, a professor of zoology at Cambridge University who led the study, concluded that an insect's wings works by encouraging air to flow over it in such a way that when the air leaves the rear edge of the wing, it moves downwards. The resultant eddy produces an upward thrust on the wing.
A later study in 2006 sought to continue the study where Weisfeld left off.
Lawrence Altscher, a researcher at the California Institute of Technology, stated that the average insect beats its wings up to 200 times per second, while the bumblebee can easily exceed 230 beats per second.
This increased flapping gives the bee the boost it needs in order to maintain flight, combined with the added lift due to the aerodynamics of its wings. This long and complicated process of discovering how bees fly is actually answered by a simple question. The wings of the bee actually flap faster in order to compensate for the large body mass of the bee. So at the end of the day, the insect that supposedly defies physics doesn't actually defy anything.